Alright students, the first catch-up video that I'm going to walk you through is going over our first chemistry test. So, what are the meanings of these terms? Closeness to true value is accuracy. Let's say D there. Narrowness of range of measurements. That one was a mistake on the test, just a freebie, so go ahead and select C. The non-SI scale for temperature would be the Celsius temperature scale. The SI scale is Kelvin. The quantity of matter an object contains, that would be mass, E. The length is meter, that's A. Volume, liters. Where's liters? No, B, volume. Okay. Alright, now let's go over, we have a little expressing in scientific notation problems. So, how do you express 0.0000000000154 meters in scientific notation? So we need the decimal to appear after the first non-zero number, so after that 1. Every 3 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we move the decimal 10 to the right. So we're going to start with 1.54, and our answer is either going to be positive 10 or negative 10. When you move it to the right, you're making this value bigger. So we're going to need a placeholder value that's going to make it smaller, which will be 10 to the negative 10th. If you multiply 1.54 times 10 to the negative 10th, it returns you back to this smaller number. Because 10 to the negative 10th is 0.09 more zeros, 1. So the answer there is D. Some people just go ahead and remember when you move it to the right, you're making it negative, and when you're moving it to the left, you're making it positive. Okay. The expression of 5.008 kilometers in scientific notation is, so we need the decimal to go to the left, 1, 2, 3. It'll be 5.008. So it's going to be either this one, or this one. I said by moving the decimal to the left, we're making this thing appear smaller, which means we're going to need a multiplier that's going to make it bigger. So 10 to the third, not 10 to the negative third. 10 to the third is 10 times 10 times 10, which is 1,000. So 5.008 times 1,000 is going to give us back our 5,008 kilometers. So A is the answer for that. Which of the following measurements is expressed to 3 significant figures? So these zeros here are just placeholders. If you express that in scientific notation, it would be 7 times 10 to the negative second. 1, 2, 3. No, excuse me, 10 to the negative third. Here we have 4 significant figures. Here we have 3 significant figures. And here we have 2 significant figures. This 0 is significant because it's on the back end of a non-zero number behind a decimal. Remember, all zeros behind a decimal are believed to be accurate and significant. So this is our answer. 1, 2, 3 significant figures. Remember, these are just placeholder factors. Placeholder factors. Placeholder factors. Placeholder factors. These are significant. These are significant. These are significant. So the answer to this one with the 3 significant digits is C. In the measurement 0.503 liters, which digit is the estimated digit? The last digit is always the estimated digit. So that would be the 3. Think about the graduated cylinder. I'll scroll down here to show you one of those. Here for this graduated cylinder, you know that this is 21, 22, 23, 24, 25, and then here's 26. So this line here, this meniscus, is somewhere between 25 and 26. You need to estimate that last digit, which I would say that one is something like 25.2 milliliters. Scrolling back up, so that last digit is always going to be the one that you estimate no matter what. How many significant figures are in the measurement 0.0034 kilograms? Remember, leading zeros are not significant, which means only these non-zero numbers are significant here. So A is the answer there. How many significant figures are in the measurement 8.1140 grams, or 811.40 grams? Remember, as I said up above, a zero behind a non-zero number behind a decimal is significant. And any zero, for that matter, behind a decimal is going to be significant. So the answer, that's 5. D. And what is the SI unit of mass? Kilogram. D. All right. So what is the quantity 0.0075 meters expressed in centimeters? So we had that King Henry died by drinking chocolate milk. Apparently had a chocolate allergy. I imagine it exists somewhere. Or just incredibly sensitive lactose intolerance, one of the two. What is the quantity of 0.0075 measured meters expressed in centimeters? So meters is the base unit. So we're starting here on the ladder, or the steps. We're going to walk our way down to centimeters, which is 1, 2, to smaller units. Centimeters are much smaller units than meters, so that's going to turn this into a bigger number since they're smaller units. So we're moving the decimal place over to make this number bigger, again, since we'll have more smaller units. 1, 2, the answer should be 0.75 centimeters. That's B. What is the quantity 7,896 millimeters expressed in meters? So here we're starting here at the bottom of our step ladder, and we're going to walk the way up it 2 meters. 1, 2, 3. So since we're going to meters, and that's a bigger unit, we're going to have less of that unit than if we had little tiny millimeter units. So we're going to start with our decimal right here. And remember, we moved it 1, 2, 3 places over. 1, 2, 3. So it should be 7.896 meters. A. All right. What is the quantity 987 milligrams expressed in grams? Similar problem. We're going to be walking up our step ladder from milligrams to grams, because grams is the base unit. 1, 2, 3 steps up. So we're going from a smaller unit of milligrams to a bigger unit of grams. So we're going to expect this to be a smaller number. We're going to move the decimal over 1, 2, 3 place. So let's go to 1, 2, 3 place, which will be 0.987 grams. B. Which of the following equalities is not correct? Use the table above to help you. I don't think this table above is the one that I intended to be helpful for that problem. Probably could be. Like if we start with grams here, put grams at the base unit, which it is, and we're going to centigrams, a smaller unit, which you would move 1, 2. If you were to turn 1 gram into 2 centigrams, a smaller unit, that would be 100 centigrams, which is correct. if you were to start with 1,000 millimeters here and go to meters, you move the decimal 1, 2, 3 places, making it in meters, which is a bigger unit. So that's going to make this a smaller number. 1, 2, 3, 1.0, which it did. This is correct. This was an equality that I taught you in class. A centimeter cubed is 1 milliliter, and you just need to remember that. And finally, we get to 10 kilograms and 1 gram. If we were to put 1 gram here as the base unit and walk our way up to kilograms, 1 gram, moving the decimal over 1, 2, 3. So how many kilograms is 1 gram? We're going to a bigger unit, starting from a smaller unit. So this number is actually going to become smaller, which means we would need to move the decimal over 1, 2, 3 places to the left, giving us 0.001 kilograms. That's obviously not 0.001 kilograms. If another way to look at this would be to walk down, because they're saying 10 kilograms equals 1 gram. If we started here with 10 kilograms and go to grams, grams is the smaller unit, so there's a lot of grams in 10 kilograms. And if we were to walk down 1, 2, 3, moving our decimal 3 places to the right would give us 10,000 grams. Taking 10 kilograms, moving 10 decimals, the 3 decimals to the right, 1, 2, 3, that would give us 10,000 grams. And obviously they didn't write that there. So D is the wrong answer. Okay, so that's the reasoning for all that. I'm actually going to put problems 18 through 26 in a separate video for a variety of reasons. So this is a good place to stop. I hope that helped, and if it didn't, you need to see me. All right, thanks for watching. Bye.